Hello, in this video we'll look at waves physics. I'm previously Twitter. Don't forget to follow my page, my YouTube channel, subscribe and like the videos. So in this video we'll be looking at waves. So first we know what a wave is. A wave is a disturbance in a medium. A wave is a disturbance in a medium that transfers energy. Okay, then we have two types of, I'm going to summarize everything. We have two types of waves. Two types. These are transverse and longitudinal. Example of transverse waves are water waves. Example of longitudinal waves are sound waves, such as radiations. Here, for example, water waves also waves in a loop. Now, so let's look at wave terms. So under wave terms, we'll start with the frequency. Frequency is the number of waves made in 1 second. Period is the time taken to make one wave. So let me just give you this example. I'll give this example. Imagine we have a transverse wave. It's moving that way. So in this case, how can you find frequency? How can you find period? Frequency, the number of waves made in 1 second. 1 second is here. Let's change the color. So 1 second is here. And how many waves? We have half, then half. Half plus half is just 1 hertz. Then period is the time taken to make one complete oscillation. One complete oscillation is like that. So we have 1 second. That's how you can find period and frequency from a graph. We can also find frequency and period by using this. Frequency is equal to 1 over period. In this case, we had the frequency. Or you can say period is equal to 1 over frequency. We already found frequency, so period is 1 over frequency. So this will be 1 over 1. So period is equal to 1 second. That's how come we came up with this. It's the other way around. A longitudinal wave has two parts. That is the rarefaction part, the rarefaction, and the compression. This is the general structure of a sound wave or any longitudinal wave. We have C, we have R as here, which means rarefaction. These are regions of low density. Or compressions are regions of high density. That's all. Now, what is wavelength? Wavelength is just the distance between two successive crests or troughs. So this is a crest, okay? Then this is a trough. So the distance between this, so I'll do this, from here to here, that's wavelength. Or from half here to another half there. So that distance to there, that's also what? A wavelength. Even from here, as long as there's this point and another point there, is what? Is also a wavelength. Now, what is amplitude? Amplitude is the maximum displacement of the wave. Maximum displacement of the wave from its rest position. So the rest position of the wave is always this line, which is 0. So in this case, the amplitude is from there to there, which is 1, or from there to there, which is also 1. So we ignore the signs. So it can either be there, or it can be down here. Now, when speed, frequency, and wavelength have been given, I can calculate them. So these three are connected by the equation. We say speed is equal to frequency times lambda. Lambda is wavelength. These are the units for the symbol for wavelength. For example, if I've got a speed of 40 meters per second, all right, and I have, let's say, speed, and I have a frequency of 10 hertz, how can I find wavelength? So I know that speed is equal to frequency times what? Wavelength. So speed, I'm going to put 40 meters per second is equal to frequency is 10 hertz times what? Wavelength. So this will be over 10 hertz over 10 hertz. You must be able to know that a hertz is just equal to 1 over second. Therefore, we cancel. So we have wavelength as 4 meters. Remember, wavelength is just distance. So you can play around this formula to find frequency, to find the speed. Let's look at some useful conventions that you can find in terms of wave or anywhere in physics. Micro. Micro means 10 to the power negative 6. So if I have, the symbol is this. So if I have 2 micro, let me say micro hertz, what I mean is 2 times 10 to the power 6 hertz, negative 6. Another one is mega. Mega means 10 to the power 6. So if I say I have 2, the symbol is M. If I say I have 2 mega hertz, I mean 2 times 10 to the power 6 hertz. Another one is kilo. Kilo, the symbol is K. Kilo means a 10 to the power 3. So it's the same as if I have 2 kilowatts, for example. I'm going to, this is the same 2 times 10 to the power 3, which is the same as 2000. So kilo just means 1,000, 2000 watts. These are some of the things that you must know. So I'll see you in the next video. Thank you for watching.